Okay, this is College Algebra, Lesson 5.4, the first video called Matrix Operations, and this will be a little bit of fresh air. If you had trouble doing 5.3, this is a lot easier of a section here, and I think what you'll find is most of the sections in the rest of this chapter are going to be easier. 5.3 seemed to be the hardest one here. Okay, whenever we name a matrix, we use a capital letter. So, like if we want to name a matrix A, that's what we use. The entries inside the matrix symbol are lowercase letters. And what happens, let's say I have a matrix that is 3, 2, 0, 1, 4, 6, 3, 6, 9. Okay, and I want to name the place value of different parts. Okay, this is the row, so this is a 1, 2, 3 row times 3 columns, so it's a 3 by 3. And if I want to talk about that, I would say that that 4 is in position 2, 2. Because what we do is, or if I just say I want to talk about the number in the position like that. This is the number, this is the entry, this is where that entry is at. Down 2, over 2. Second row, second column. And that's how you name the place of each of the numbers here. Alright, so let's say we want to add and subtract and multiply matrices. That's what we're going to do today. And we're going to look at example 1, and it says we've got A plus B. A is the matrix -5, 0, 4, 1/2. And B is the matrix 6, -3, 2, 3. And let's say we want to add those. What it would do is it would look like that. And we would add the numbers that are in the same places. Now, when you're adding or subtracting matrices, the matrices have to have the same order. So this is A is a 2 by 2, and B is a 2 by 2. So we can add those. If one of the matrices was, say, a 2 by 3, then we couldn't add them because they have to have the exact same order. Number of rows, number of columns. Number of rows, number of columns have to be the same. So what we do then is we add these numbers, these, and these. So A plus B equals that. And that's it. That's nothing weird, nothing scary. If you notice that on the B part of it, they have a 3 by 2 for A and a 3 by 2 for B. So you can add those together without any problem. And it's done the same way. I'm not even going to go over that because that would be kind of redundant. Alright, when you get to subtraction, same thing, only you're subtracting the numbers instead of adding them. And the only thing I would suggest you pay attention to is the double negatives. So let me put A on here, and let's just do that one, and I'll leave B up to you. And we'll go from there. So if we want to subtract, we're going to do 1 minus 1, 2 minus -1, -2 minus 1, 0 minus 3, -3 minus 2, and -1 minus 3. And we're done. Okay? Notice the B part of this example too. It has C equals 5, -6, -3, 4. And then it has D equal to -4, 1. Alright, so this one here is a 2 by 2, and this one is a 2 by 1. They're not the same. They're not the same order. One's a 2 by 2, one's a 2 by 1, so it cannot be done. So you just say can't be done. So what if we want to write the opposite, or the additive inverse? So let's say that's the additive inverse of that. Okay, so if I have A, and this is example 3, and I want to know what the additive inverse is. Very simple. All I do is change the sign. And that is A to the negative 1, the inverse. Now, one of the things that you'll know about adding A to its inverse is you get 0. Kind of like taking 1 plus negative 1 gives you 0. Same thing is true with your matrices. And when we get zeros, what we end up getting for an answer for this, when we add those, is 0, 0, 0, 0, 0, 0. And this is called the zero matrix. And the zero matrix has an additive identity, which means when you add it to, if I were to take this and add it to this, I would get this back. Okay, it's just like 1 plus 0 equals 1. This matrix plus zeros gives us this matrix. All right, next section is called scalar multiplication. And again, pretty simple to do. If I am interested in finding 3a, that means I'm taking 3 times the matrix. And if a is equal to negative 3, 0, 4, and 5, like that. All right, and I'm taking 3 times it, it would be like that. And I take 3 times each of these parts. And I get that for an answer. Okay? Not too terrible there. Which brings us up to example number 5. Example number 5, we're using a story problem, and you've got this Mitchell Fabricators, and they make bicycles, and they make 3 different styles of bicycles. Let me put that picture up here. All right, so let's look and see what we've got here. We've got 2 plants that make bicycles. They make these 3 types. This is the bikes that this place makes, and this, or a month. This is the month of April, this whole thing. All right, so that's the information they give us here. First thing A says is write a 2 by 3 matrix. Well, 2 by 3 matrix, 150, 120, 100, 180, 90, and 130. So there's my 2 by 3 matrix based on the information that I get there. So that part's done. B, the manufacturer increased production of each style by 20% in May. So this is April. Let me get a color that's actually going to show up. So this is April. We're increasing production by 20%. So if I take 20% and increase this amount, what will that look like? Well, I'm increasing by 20%, so I'm using whatever I made in April, which is 100%, and I'm increasing it by another 20%. So I'm multiplying each one of these by 120%. So it's going to look like it's 1.2, changing it to decimal, 150, 120, 100, 180, 90, 130. And we use scalar multiplication. This times this, and that will give us our numbers for May if we multiply all those by 1.2. And when we do that, our May picture, let's get rid of this, our May matrix will look like this. 180, 150 times 1.2, 144, 120, and then 216, 108, and 156. So again, the way I got that is I just took this times 120%, because they increased it by 20%. So they not only made 150 bikes, but they made an additional 20% bikes on top of that. So 20% of 150 is going to be 30. So whatever they made, 150 plus another 30, increasing it by 20%, is where we got our 180. So you could either take 20% of each of these and add it to each one of these numbers to get these, or you could just take each one of these numbers times 120% or 1.2 and get the same thing. All right, so C says, find the matrix A plus M. So they want to do the matrix A plus M. And that would equal this amount plus this amount. So that would give me 330. This amount and this amount, 264. This amount and this amount. Okay, you kind of get the hang of what I'm doing there, rather than saying this amount and this amount over and over. We get all of these numbers. All right, so what does this represent? It represents the total number of bikes sold in April and the total amount sold in May. And that's what this number is. So at the North Plant, they sold 330 mountain bikes in April and May. At the South Plant, they sold that in that. Okay, so what we're going to be doing next is called products of matrices. And this isn't really that difficult. It can be a little confusing on how to get started on it, but after teaching this for years and years, I've kind of figured out a pattern that hopefully this will make it easy to multiply matrices. So you've added, you subtracted, you've multiplied by a scalar, 5 times each one of these parts of the matrix. But now we're going to take one matrix and multiply it by another matrix. All right, and we'll save that for the next video since I'm pretty much running out of time here.